In today's video, I'm going to explain the quantum numbers, break them down, know what they really are, and what each one of them really represents. So let's get started. Firstly, you have to know that there are four quantum numbers. And the first one we have is called the principal quantum number. And the symbol corresponds to it is the letter N. Basically, the principal quantum number is the number of the energy level in an atom, where the electrons orbits in. So let's say you have a nucleus, some energy levels, K, L, M, 1, 2, 3. You see those numbers? These are the principal quantum numbers. And you have to know that N has to be a whole integer, ranging from 1 to 7. Because as you know, there are 7 energy levels in the biggest known atom. And that is what you need to know about the principal quantum number, or N. The second quantum number we have is called the angular momentum quantum number, and the symbol corresponds to it is the letter L. And it basically describes the shape of the sublevel. And you have to know that you got four sublevels. The first one is S, which is a sphere. Second one is P, there is D, and there is F. You also have to know that the angular momentum quantum number, or L for S, is 0, for P is 1, for D is 2, and for F, L equals 3. Now let's talk about the relationship between N and L. You have to know that L is always smaller than or equal to N minus 1. So if N equals 1, then L only has one value, which is N minus 1, which is 0. If N equals 2, according to the equation, 2 minus 1 equals 1, then L can be either 0 or it can be also 1. If N equals 3, then L can equal to 0, 1, and also 2. If N equals 4, then L can be 0, 1, 2, and 3. As you can remember, when L equals 0, this is the S sublevel. So you can find the S sublevel in the first energy level. For the second energy level, you got L equals 0 and 1, meaning you can find the sublevel S and the sublevel P. For the next sublevel, for the next energy level, I mean, which is the third one, you can find the sublevel S, P, and D. And for the last one, which is the fourth energy level, you can find the sublevel S, the sublevel B, D, and the sublevel F. Now that you might notice that there is no 1P, it doesn't exist. The sublevel B doesn't even exist in the first energy level. But as you can see, it starts appearing in the second energy level here. So you can find 2P, but 1P doesn't exist. Same thing with the sublevel D. It starts appearing at the energy level 3, so you can't find 1D, you can't find 2D, but you can find 3D, 4D, and so on. Same thing with the sublevel F. It starts appearing in the energy level 4, so you can find 1F, 2F, 3F. Can't find all of that, but you can find 4F, 5F, and so on. Alright, so here's a question for you. What is the N value and the L value that corresponds to the sublevel 4D? This number or this integer is the n value, which is 4, meaning it's in the fourth energy level. And the L for D, as you can memorize it, L for S is 0, for P is 1, for D is 2, and for F is 3. So in that case, L equals 2. Let's try with 4F. The n value, as we said, is the coefficient right here, which is 4. And the L value for F, as you can remember, 0, 1, 2, 3. It was 3. The third quantum number we have is called the magnetic quantum number, and the simple corresponds to it is m sub L. So the magnetic quantum number is the number of the orbital. So what is the orbital? So the orbital is basically a region in space where the probability of finding an electron in it is very high. And you can find the electrons having either an upspin or a downspin. So now let's talk about the relationship between the angular momentum quantum number and the magnetic quantum number. So when L equals 0, which is the S sublevel, the ML or the magnetic quantum number for it can only be 0. When L equals 1, which is the P sublevel, ML can either be -1, 0, or +1. When L equals 2, which is the D sublevel, ML can be either -2, -1, 0, +1, or +2. When L equals 3, which is the last sublevel, which is F, the ML can be either -3, -2, -1, 0, +1, +2, or +3. And we can conclude something from that, which is that ML is between -L and +L. So let's say if L is 0, then ML can only be 0. If L is 1, then ML is between -1 and +1, meaning it can be -1, 0, or +1. Same thing with the second and third one. Let's also see this one, which is for F. You note that the L for F is 3, and it has 7 orbitals. And you know that ML is between -L and +L, right? So ML can be -3, -2, -1, 0, 1, 2, 3. And it can hold up to 7 multiplied by 2 is 14 electrons. It's really simple. Right, so for the last quantum number, which is the electron spin, and you have to know that the symbol corresponds to it is m sub s, and ms can either be positive half or negative half. If the electron is going up, then ms equals positive half. If it's going down, then ms equals negative half. So if you have 3 orbitals having these electrons, what is the ms and ml for this electron? Know that this is the p sublevel, so ml equals 0, which is the 0 orbital, and this electron is going up, so the ms, or the electron spin, is positive half. Alright, so this is just a quick note on how to get the number of orbitals from n and L. So let's say you have L equals 2, which is the D sublevel. The law says 2L plus 1 equals the number of orbitals in the sublevel. So you know that you have 5 orbitals in the sublevel D, right? So let's apply the law here. We have L equals 2, which is 4 plus 1 equals 5, right? What about the F block, the F sublevel, I mean, which has L equals 3. You know that it has 7 orbitals, right? Let's apply the law here. 6 plus 1 equals 7. Okay, what about getting the number of orbitals from the n, or the principal quantum number? You can just square it. Let's say in the second um, energy level, or n equals 2, you have n squared, which is 2 power 2, equals 4 orbitals in this level. Because as you know, when n equals 2, there is the s sub level that has 1 orbital. It also has the p sub level that has 3 orbitals. So the sum is 4 orbitals. You can also get the number of electrons per level by just multiplying the n squared by 2. So the law is 2n squared, because each orbital can carry up to 2 electrons. Now let's see this example. We have 3D 8. We need to get all the quantum numbers, the 4 quantum numbers, for this electron. So firstly, the n is the principal quantum number, the number of the energy level, which is 3. Second one, which is L, the angular momentum quantum number. And as you know, for D, the L is 2. And as you know, for D, you have 5 orbitals. It's 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And do you know that ML is between negative L and positive L? So it's negative 2, negative 1, 0, positive 1, and positive 2. So for the 8th electron, which is that one, the ML is 0. What about the MS? It's going down, right? So the MS is negative half. And now you have the N, the L, the ML, and the MS.